Now, this is another problem from the circular motion practice based on the group teaching problems that we did in College Physics 12, where we solved 7 problems, went around to various groups. The theme among all of them was that there's some kind of centripetal force, and that centripetal force could be one single force, but it's never just a generic centripetal force. It's always something providing the centripetal force for that particular situation. So we're going to ask ourselves over and over again, in this particular situation, what forces combine to make this object move in a circle? As Zoe said, it's like you're filling in a blank. You're always asking what goes in here for F sub C. Trust me when I say do not worry about numbers when you look at the problem. Worry about the physical scenario. And what I see as a physical scenario here, first thing that catches my eye is rubber stopper in vertical circle. So I'm just going to worry about a rubber stopper in the vertical circle, and in particular the fact that it's at the top of the circle. That's what I'm going to draw. So I'm going to draw the circle in such a way that I can see it, which means I'm drawing a side view. So I'm drawing a side view of the circle. And I'll focus at the top, and I'll draw the forces. Now, if you, I will briefly draw an actual rendition of the rubber stopper moving in the circle. So if I look over here, and this is not a force diagram now, I'm going to actually draw a little rubber stopper. And there's going to be a string on this rubber stopper. So there's a string going down. There's an actual string pulling this rubber stopper down. If you think about a string pulling a rubber stopper, and then, you know, here's somebody's hand holding it. So there's a hand holding that. If you think about that, the forces that are acting on it become fairly obvious, I think. You have to have tension down because there's a string. So if here's my object, there's got to be tension down. And the rubber stopper, just like every object near the surface of the earth, has weight. So I've got weight down and tension down. There's no normal force because there's no surface, so there's no normal force. There's no friction that's acting on it, because if there was friction, it would be acting in one of those directions. But we're not concerned with that because the person is keeping it moving at a certain speed. So those are the two forces of interest. F sub C is mv squared over r. What this equation means is there's got to be some kind of force. There's got to be something making it move in a circle. And the question is, what is that something? In this case, it's a couple of things. It's force weight toward the center plus the tension toward the center. They both contribute. So it's those two together that we're filling in the blank with, equals mv squared over r. And force weight, we know we're just going to plug in mg to get that. I've pretty much solved the problem. The rest is algebra. Force weight we basically know because we have the mass of the stopper, so we know that. The tension we don't know. We're trying to solve for that. The mass we know, the speed we know, the radius we know. Some people get confused about the radius and they think, do I cut that string in half? That string length of 1.4 meters, do I cut that in half? But I think you can see here that if that was 1.4 meters, then that is from the center to the edge of the circle, which is by definition what the radius is. And then when you solve for tension, you put in all the numbers correctly, do the algebra correctly, and you will get a tension of 6.11 newtons.